Welcome to the Deep Dive, where we unpack the most compelling innovations shaping our world, giving you the insights you need to stay ahead. Today, we're plunging into a technology that honestly sounds like it's ripped directly from a futuristic novel. But it's actually revolutionizing how we construct our physical environment right now. Imagine stepping onto a bustling construction site, the skeletal framework of a new building rising all around you. But what if, maybe with just a simple glance through some smart glasses, or even just looking at a tablet, you could literally see through those concrete walls? You'd instantly visualize every hidden pipe, every electrical conduit, every HVAC duct, all laid out in 3D right where they'll eventually be. That's not science fiction anymore, That's augmented reality, or AR. It's turning this idea of seeing the unseen into a practical, almost indispensable tool for construction. We're going to explore how this incredible blend of digital blueprints with the physical world is fundamentally changing how buildings get made.
It really is a profound shift. And today, we're taking a deep dive into augmented reality, really dissecting its transformative potential for construction. Our mission, basically, is to unpack precisely how these devices, whether they're, everyday tablets workers already carry, or maybe those sophisticated headsets like the Microsoft HoloLens, how they project incredibly detailed 3D building information models, BIM, directly into the real world. And this isn't just like cool graphics. It allows workers to actively see through walls, to understand complex systems, prevent costly errors, and crucially enhance safety. Big time. We'll also get into the huge benefits, the quantifiable ones, and importantly, look at the practical challenges, the hurdles for wider adoption. So by the end, you'll have a really solid grasp of this fast-moving field and what it means for how we build things.
Absolutely. That idea, that vision of seeing the invisible layers, it's not just for movies anymore. It's happening right now on actual job sites, bringing a level of clarity of control that was pretty much unimaginable just a decade ago. It really is exciting to see these technologies move from theory to practice, making a real difference. But to really get this leap, we first need to understand what came before AR, right? The foundation it's built on. We need to talk about moving beyond those traditional flat blueprints, the foundation, from blueprints to building information models, BIM.
Okay, so before we jump into the almost magical side of AR, let's step back. What is it actually augmenting? Traditionally, for centuries really, construction has relied on flat 2D drawings. Think about that. A complex building, all these intricate systems, precise connections, all boiled down to lines on paper. That's a huge leap of interpretation needed from, everyone trying to build it.
Exactly. And that leap, that translation, that's where so many problems and frankly, costs have always come from. Translating those 2D drawings, those abstract lines, into 3D physical reality, that's always been a major struggle. It leads to errors, rework, delays. You name it. There's a great example from the Book House. It really brings this home. You've got these two experienced carpenters, Jim and Richard. They're installing the sills, the very first wood pieces on the foundation. Super critical step, right? Sets up everything else. And they hit this, seemingly tiny problem. The sills stick out over the foundation edge just a little too far. They measure carefully. The 2x6 pine boards, they're supposed to be 5.5 inches wide. It's standard. But they're 5 5/8, an eighth of an inch difference. Just a tiny fraction. Maybe sawn wrong, or more likely they set outside, absorbed a bit of water. Happens all the time with wood. But that tiny eighth of an inch, it meant they couldn't make the house exactly 30 feet and 1/4 inches wide right at the start. So think about it. You got to pull everything off, recalibrate, start over. Right at the beginning. It just shows how a minuscule physical variation can cause real delays, real rework from day one.
An eighth of an inch. Wow. It's incredible how that tiny detail just throws everything off, forces you to redo work right away. It really highlights that constant fight against imprecision in the physical world. And if that happens with basic structure, I can only imagine how much harder it gets with complex architectural details or where different systems meet.
You've nailed it. That's another key point. The sources show this difficulty with complex details again and again. Think about something like fitting intricate cornice or crown molding, the decorative stuff. Even with detailed drawings, the Book House describes the carpenters crouched on the kitchen floor trying to solve that problem. How do you actually build this specific detail? How does the molding meet the eaves exactly? It's not just looks. It's about getting the angles right, the cuts perfect. Otherwise, it looks bad or even compromises the building envelope. This kind of on-site problem solving, the trial and error, it's super common because the 2D drawing just can't capture all the 3D nuance. And, the translation challenge isn't new. It's basically as old as building itself. If you look back historically, Texts like Lectures on Architecture from the 18th century mention architects designing plans on paper without really thinking much about the prospective results, the 3D reality. It suggests this long-standing gap between the 2D concept and the 3D outcome. Even way back, precision was key, right? Medieval builders calculating column thickness for cathedrals, or early 20th century handbooks detailing structural elements. They had methods, sure, but translating that drawing always involved risk, interpretation, a lot of skill that wasn't written down. The mental load on the builder was just immense.
Okay, so we've got the picture. 2D drawings have real limitations. They've served us well, but they create challenges. And this is where it gets really interesting, because this is where building information modeling, BIM, comes in. It's the digital foundation, the backbone, that makes AR possible. It's not just drawing better, is it? It's a whole different way of thinking about the project.
Exactly right. BIM is a genuine paradigm shift, as the BIM handbook puts it. It's moving from drawing to modeling. And it's way, way more than just fancy 3D CAD, which mostly just deals with geometry, the shapes. What's powerful about BIM is that it's fundamentally an intelligent, comprehensive database. It captures all of the physical and functional characteristics of every element in a database format. That's from Construction Management Jumpstart. So think about it. Inside that single digital model, you've got data on everything. The R value of the insulation, like you'd find specified in the builder's guide, critical for energy efficiency. Or the exact reinforcement details in a concrete beam size, material, placement, like you'd see illustrated in Building Construction Illustrated. But it goes further. Manufacturer specs, costs, schedules, energy performance data, even how to maintain it later, all linked to the specific components in the model.
Wow. So it's not just a 3D picture. It's like the building's entire digital DNA, all connected in one place. That must make collaboration way easier, right? Because everyone, architects and engineers, contractors, work off the same super detailed master plan, not trying to match up different drawings.
That's the core advantage, absolutely. This integrated, data-rich environment is key. The BIM handbook points out that BIM helps drive a shift towards more collaborative ways of working, less working in silos. Because everyone's using and adding to the same central model, you spot conflicts much, much earlier, during design, not during construction. And this model lets designers run all sorts of simulations. What-if scenarios. They can check impacts on energy efficiency, to ADA compliance, to spatial relationships, like construction management jumpstart details. This integrated approach, this predictive power, it's huge. It lets teams find and fix problems virtually, like, that pipe trying to run through a beam, or an electrical conduit clashing with an HVAC duct. You solve that with a mouse click in the model, not with a saw or a delay on site. It avoids those Jim and Richard moments. It saves incredible amounts of time, material, money. And it clarifies those tricky hidden details like air barriers or vapor retarders from the builder's guide, making sure they're right from the start. Yeah. Augmented reality, bridging the digital-physical divide.
Okay, so BIM lays the digital groundwork. We've built the project's DNA in incredible detail, solved problems virtually. Now let's talk about giving that blueprint eyes on the job site. How does all that rich digital info become a visible advantage for the worker? How do they finally see through walls?
Right. This is where AR steps in and really becomes the game changer. It's the tech that bridges that digital-physical gap. Essentially, AR projects 3D BIM models into the real world at a one-to-one scale right there on the job site. So imagine standing in a half-built room. You look through a device, and boom, you see a perfectly aligned see-through overlay of the final design. It's like the digital model just materialized around you full size. It gives you context-aware info, blending the virtual stuff with what you're actually seeing. And this happens through different devices. You've got like tablets. Lots of workers have those already. They give you a sort of window into the augmented view. Or you have the more advanced stuff, the hands-free headsets like the Microsoft HoloLens. That's more immersive, lets you walk around, interact with gestures, voice commands. But the core power, the really cool part, is that ability to, literally see through walls. It's not just a phrase. You can visualize the complex guts of the building, the mechanical, electrical, plumbing, the MEP systems, or structural things hidden behind drywall or concrete. So you're looking at a concrete wall. AR can show you the rebar cage inside, exact spacing, overlaps, everything, or where the electrical conduits are supposed to run. For modern buildings, this is huge for those hidden but critical things like air barriers or vapor retarders mentioned in the builder's guide. You can see exactly where they go. It gives you this unparalleled insight.
That's incredible. I can immediately see how that cuts down on mistakes, on guesswork, especially when you've got multiple trades, plumbers, electricians, HVAC guys all trying to fit their stuff into the same tight spaces. So it sounds like AR isn't just a neat gadget. It's a tool with really specific, powerful uses beyond just looking cool.
Absolutely right. It's far more than a novelty. One of the biggest applications, maybe the main reason people adopt it, is clash detection and error prevention. AR lets you solve problems proactively right there by letting workers see the complex layout of MEP systems before anything gets installed. Think about a common situation. A big HVAC duct is supposed to fit according to the 2D plans, but in reality, maybe because the site's slightly off or someone read the plan wrong, it's about to hit a structural beam or a fire sprinkler line. Normally, you only find that out when the HVAC crew tries to hang the duct. Work stops, people get frustrated. You redesign, reorder, reinstall. Major headache. With AR, though, a worker looks at the space, sees the digital duct trying to occupy the same spot as the digital beam. Instant red flag, conflict. They can identify it, maybe snap a photo, add a note right on the augmented view, send it back to the design team, and it gets resolved virtually, quickly, before any material is cut, before any time is wasted. This hits a massive pain point in construction. Change orders. Construction Management Jumpstart says it clearly. Flaws, errors, or omissions result in a change order. And change orders mean extra work and extra time, costing the owner money. These costs can be huge. Project management in construction talks about job delays, even liquidated damages, penalties for finishing late. AR acts as this crucial visual check, this risk mitigation tool. It can save thousands, potentially millions, by catching these clashes before they become physical problems.
And it's not just stopping bad things from happening, which is obviously massive. It's also about making sure everything is built exactly right. It's a spec, down to the millimeter. I mean, imagine a huge project where precision is everything. Every single piece has to be perfect for it to work long term.
Precisely. Which brings us to the second key use. Quality control and layout verification. AR helps maintain super high standards of precision. Think about something complex like tilt-up concrete construction, where they cast these huge wall panels flat on the ground, then lift them up. Getting the placement of the connectors, the dowels and shear keys that tie those panels to the foundation and to each other absolutely perfect is vital for structural integrity. With AR, a worker could project the BIM model onto the foundation or the panel and instantly check. Is every single dowel, every key, exactly where it needs to be? Ensures it's built right. This is also critical for meeting strict building codes, like those outlined in Building Codes Illustrated. For example, AR could verify fire stopping. If a pipe goes through a fire-rated wall, is it sealed correctly to stop fire spread? AR can overlay the requirement, making it easy to check. Or verifying sprayed fire-resistant material on steel beams. Does it meet the required thickness, density, bond strength? AR could help check against the code requirements during inspection. These are things hard to check accurately with just eyeballs and a tape measure. And for really advanced stuff, like buildings with heating and cooling pipes embedded inside the concrete floors, as sustainable construction describes, AR could guide that installation with pinpoint accuracy, making sure the pipes are embedded correctly, avoiding thermal bridges that waste energy or cause condensation later. It really elevates the quality control. Digital certainty.
I definitely see the power there for precision. But what about when you hit a snag on site? Something unexpected happens, and you need an expert's opinion. But they're not there. Maybe they're miles away. Construction sites can be huge, sometimes remote. Getting the right expert advice quickly can be tough logistically.
Yeah, and that's where AR's third killer app comes in, remote assistance and expert guidance. This really changes how expertise gets delivered. AR lets an expert see precisely what a field worker sees in real time and provide real-time guidance right in their view. So picture this. A technician on site is wrestling with some complex equipment install. They're stuck. They put on their AR headset. An expert engineer, maybe back at the main office, hundreds of miles away, sees exactly what the tech sees through the headset's camera. The expert can then draw arrows, highlight components, display instructions or diagrams digitally, overlaid onto the real equipment in the technician's view. It's an amazing form of stakeholder engagement, as the PMBO guide calls it. You get immediate, high-quality help without travel delays or costs. The CMAA, Construction Management Standards of Practice, actually recommends having an on-site model available, like a virtual plan room. Well, AR basically puts that virtual plan room right onto the job site in context. Everyone sees the latest model. And experts can guide hands-on work from anywhere. It kind of democratizes expertise. Speeds up problem solving, ensures quality, even way out in the field.
And it's not just about seeing what's there now or fixing current problems. It can also show what will be there based on the plan and schedule, right? That sounds like some seriously advanced planning power, like a crystal ball for the job site.
That's a great way to put it. Which leads to the fourth key application, advanced planning and visualization. AR takes sophisticated BIM stuff, like 4D scheduling, that's the 3D model plus the time dimension, and makes it super practical on site. The CMAA standards of practice say using the 4D model helps visualize deviations from the plan. With AR, you overlay that 4D schedule right onto the physical site. So you see not just what to build, but when it should be built, how the sequence should unfold. You can walk around and compare actual progress against the plan right there, visually. Spot delays instantly. Like a project manager walks through an area, they can see digital ghosts of the walls or systems that should have been installed last week, immediately flags a problem area. It also extends those what-if scenarios from BIM, mentioned in Construction Management Jumpstart, right onto the site. You can make immediate decisions based on visual data. You could virtually test fit upcoming phases, check material laydown areas, logistics, or visualize those hidden but crucial things, like the specific insulation or air barriers from the builder's guide. Making sure they're installed perfectly before they get covered up forever, it just brings the whole plan to life with amazing clarity. 3, the value proposition, why AR is becoming indispensable.
Okay, so it's crystal clear AR isn't just cool tech. It delivers real, measurable value, impacts the bottom line, project success. In an industry like construction, which is so complex, so cost-sensitive, what are the really tangible, quantifiable benefits AR brings?
Yeah, the benefits are definitely quantifiable, making it increasingly vital. First off, AR dramatically drives improved accuracy and precision. And it's more than just catching mistakes. It's about predictive precision. You get that immediate one-to-one comparison about here's the design model, here's the physical reality. Spot discrepancies instantly, even tiny ones. This helps teams trace an undesirable effect back to its root cause, like the PMBOK guide suggests. It helps cut down on that human error, lack of imagination, the stuff that leads to mistakes, as the existential pleasures of engineering puts it. Think about visualizing wood grain direction, like understanding wood discusses, before cutting a structural beam, making sure cuts are made for maximum strength, or maybe anticipating how wood might warp as it dries before it causes nail pops in the finished drywall, a common issue from the builder's guide. AR gives you that foresight, that control. It's like debugging the physical build before it happens. That changes everything: waste, timelines, quality.
And if you're preventing errors that precisely,
Yeah.
the next logical benefit has to be a massive reduction in rework,
Right.
which must massively impact the budget.
Exactly. They're directly linked. The second huge benefit is reduced rework and cost savings. Immense cost savings. By catching conflicts, installation errors, deviations early before you order the wrong stuff, cut things wrong, install improperly, AR slashes the need for rework, and that translates directly into significant cost savings, a core goal in project management, highlighted everywhere from the PMBOK guide to construction project management. Preventing errors can significantly reduce the need for redesign because of cost overruns, says the CMAA Standards of Practice. Think about a big project. One unnoticed clash, say, between a major pipe and a foundation element, that could mean weeks of delay. Re-engineering, refabricating, getting crews back. Easily hundreds of thousands, maybe millions in costs and penalties. AR acts as this critical risk mitigator. It shields projects from those kinds of financial hits that used to feel almost unavoidable. It directly boosts the project's business value, which the PMBO guide defines as that net quantifiable benefit. In an industry often hit by overruns, this is truly game-changing, moving from reactive problem-solving to proactive management.
Beyond the money and efficiency, there's the human side. Safety is paramount on any job site. It sounds like AR has a surprisingly big role to play there too, more than just ticking boxes.
Absolutely. And this might be one of the most compelling benefits. AR directly enhances safety by giving workers instant access to critical, often invisible information. Think about common site hazards. Excavation, for example. AR can visualize buried utilities, gas lines, electric, water before digging starts, prevents accidental strikes, which can be catastrophic. Or it can highlight live electrical conduits hidden in walls during renovation, or critical structural elements you shouldn't disturb. It also helps ensure safety features are installed correctly. Means of egress, fire-stopping penetrations like building codes, illustrated details. AR helps verify placement against the code, protecting workers and future occupants. Imagine AR guiding where to put fall protection anchors correctly, or showing the safe path for heavy equipment. This real-time contextual info helps workers make safer decisions, avoid hazards proactively. It really reduces accidents. It makes safety an active, real-time shield, not just a checklist.
This really feels like more than just an incremental improvement. It feels like part of a much larger shift in how we build, how we interact with the physical world, a turning point for the industry.
It absolutely is. You can definitely place AR within that broader context of the third digital revolution, a term Neil Gershenfeld uses in designing reality. This era isn't just about faster computers, it's about technology improving exponentially, yeah, but fundamentally blurring the lines between digital and physical. AR is a prime example. It's blending the digital and physical worlds, creating new best practices for the industry. We're not just designing digitally anymore, we're experiencing and building digitally in a way. And, connecting this to a bigger vision, AR really enables what the City of Tomorrow calls collaborative futurecraft. This idea of urban life, where physical and digital space converge, where environments are smarter, more responsive. AR empowers this by letting everyone involved, designers, engineers, contractors, remote experts, even building operators later on see and interact with the same digital model overlaid on reality simultaneously. This shared understanding fosters incredible collaboration. It lets us collectively design and build our future environments with way more foresight and integration than before. It's like collective intelligence for building. And finally, looking at it through a systems lens, like Donella Meadows talks about in Thinking in Systems, AR helps avoid system traps. These traps often happen because of bad or slow feedback, decisions made without good, timely info. AR provides much richer, faster feedback right on site. It makes invisible problems visible. This lets teams make better informed decisions, improving overall project performance. It helps break cycles where you're just treating symptoms, not root causes, because the critical data is right there, visible, actionable. It makes the whole building process smarter, more responsive. YB, current challenges to wider adoption.
Okay, so the potential is huge. The benefits are clear. But like any emerging tech, there are always hurdles, right? Practical challenges. What's stopping AR from being on every single construction site right now? What are the main obstacles?
That's a really important question. The vision is great, but the reality of construction sites throws up some unique challenges for AR. A big one is definitely hardware limitations. Construction sites are just brutal environments. We're talking dust, mud, rain, impacts, drops, extreme temperatures. Devices need incredible ruggedness and durability. Consumer electronics, even rugged office gear, often just won't cut it. Designing something tough enough while keeping screens sharp and components working is a real engineering challenge. And beyond just surviving, battery life is absolutely crucial. Workers need these things to last a full shift or close to it. Constant recharging, swapping batteries, that kills productivity, undermines the whole point. Imagine your headset dying mid-inspection on a huge site. Not good. And then there's the cost. Sophisticated headsets like the HoloLens are a significant investment. Trying to equip a large workforce, especially for smaller companies, that's a major financial barrier. Plus software, maintenance, support, it all adds up.
That makes total sense. The hardware has to be tough and last all day. And affordable. But even if you have the perfect device, it needs data, right? Getting reliable connectivity on a chaotic, often remote construction site sounds like another huge headache.
You've hit another major one, connectivity and data management. That's huge. For AR to work well, especially streaming those complex 3D BIM models, you need reliable on-site connectivity, high bandwidth. But sites are often sprawling, maybe remote with bad cell service, maybe temporary structures block signals. Getting stable Wi-Fi or 5G everywhere is tough. Signal dead zones, interference from equipment. It can make the AR experience laggy or just fail completely, which is worse than useless. And it's not just getting the signal, it's managing the data itself. Model management and updates. The CMAA standards of practice stress defining who updates the model, when, how. Keeping that central BIM model current with design changes, field fixes, as-built info, that's a constant effort. If the AR system is showing an outdated model, it could actually cause errors instead of preventing them. So you need solid processes for version control, data integrity, security, making sure everyone's seeing the right validated information. And finally, there's integration and training. You can't just hand someone the headset and expect magic. We know from things like high-performance green building, mentioned in sustainable construction, that complex projects already need tons of coordination. AR adds another layer. So effective adoption needs new skills. It needs good training. But it also means changing existing workflows, getting people comfortable with new tech, overcoming that we've always done it this way mindset, that cultural shift, integrating it smoothly into how work actually gets done. That's a big organizational challenge. It's about empowering people with the tech, not just deploying the tech itself.
Wow. This has been an absolutely fantastic deep dive. It's so clear how AR is fundamentally changing construction, from stopping those costly clashes and cutting rework to making sites safer and enabling collaboration across distances, all powered by BIM. It really feels like we're moving towards a future where that line between digital design and physical reality just gets blurrier and blurrier.
It really does. And here's something fascinating to think about. If AR lets us perfectly overlay digital plans onto reality, And if the third digital revolution, as Gershenfeld describes it, points to a future where materials become programmable, where the distinction between a machine and what it makes then disappears, then what happens to craftsmanship? What new skills emerge on the job site? If the burden of precision shifts more to intelligent systems, how does our whole understanding of building change when digital and physical are so tightly interwoven? Will builders become more like conductors of digital information? Or will we see a completely new blend of traditional craft and digital code? That's the exciting question, isn't it?
That is a truly provocative thought. The future of construction is clearly being reimagined right now, pushing boundaries. We really encourage you to keep watching this space. Imagine the incredible things we'll build with this collaborative future craft. Thanks so much for joining us for this deep dive. We'll see you next time.